Mr. K. Srinath, who is the Vice President of Machine Tools, Mac Machine Tools and Automation Systems Integrator, and a President of the Indian Society of Automation, that is ISA Bangalore Section. Coming with an engineering background, he has MMS with over 3 decades of professional experience in multiple functions, both in India and abroad. Mr. Srinath is a leader in enabling manufacturing companies to transform innovatively through the use of Industry 4.0, industrial automation and robotics, and software technologies. He was a business and a technology leader and has expertise in enabling technologies. For the last 5 years, Mr. Srinath has been working with SMEs and startups, helping with growth strategies. Today, Mr. Srinath will give us a brief view of use of autonomous mobile robots for internal logistics and manufacturing. So delegates, let's welcome Mr. Srinath.
So I don't know exactly what's the participation mix, but I'm presuming most of them are with some background in manufacturing. So we're talking this autonomous mobile robots in the context of manufacturing today. Though autonomous mobile robots has a variety of applications that you can touch upon. To start with, let me set the context with an understanding as to what is actually, my screen is not changing for a second. Okay, I think it has changed. Are you able to see the second screen? I wanted to start with some of the trends that we see, which is actually encouraging some of these technologies to come to play. Of course, the COVID has changed, and I'm going to bring that context as well. But even without COVID, we were seeing some economies quite largely changing their business models. Now, COVID has forced it even further. Many companies who assumed what they were doing was perfectly fine and wonderful has changed, and they had to reinvent themselves, and they had to redo things or change the way they were doing things or invent new things to do. So that's something that you have to keep in the context. The other part is consumers. We as consumers of various products, our demands have gone on the manufacturing companies quite high. Today, I want to personalize what I want to buy, be it a car, the steering in the car, or whether it is a suspension or a tire which I am getting it in the car. I do want choices. I want to be able to make choices which is to my liking. And the manufacturers have their challenges to figure out how they produce it to my choice. And of course, all this is leading to, requirements which are expanding manufacturing. But as you expand manufacturing and production, do you have enough people to serve manufacturing? And this is an unfortunate part because manufacturing is not a cool job. It's not a job which is in an air-conditioned room where you sit and write some codes, but it's hard work. Most times in front of tough environments, like in front of ovens or anything. So not many people enjoy as much. Unless they really like manufacturing. Given a choice, they don't like their environment there. So generally, it's harder to attract labor to do manufacturing. Added to that, there are global competitions. There are needs for flexibility in manufacturing. People are talking about being able to be agile and flexible to be able to move manufacturing from one location to another without the pains of doing that. So there's a variety of things which is pushing the manufacturing to the next level. One is an external challenge which is coming through the trends in the market. The other is their own internal challenges and their own competitive pressures, right? And there is a solution that they're looking to, and they are still in the journey of finding solutions for it. And some of the solutions we will talk today is addressing some of these challenges in its own ways. So we will talk about these. But what is being looked upon is a little bit of more flexibility, agility, ability to do that with speed, and ability to do that with the people involved. And that is what the solutions look like. With that, I just quickly wanted to talk about specifically the topic today, the internal logistics. And today, most of the internal logistics that you see today in manufacturing are either done through manned forklifts or AGVs or static conveyors. And AGVs is something that has come in the last few years. It wasn't there a few years back, many years back, because most of them were manned forklifts or static conveyors or use of special purpose conveying equipment. Now that is changing, and the first step was to change to AGVs, but there is the next step which companies are taking is making it even more agile by creating what is called as the autonomous mobile robots. And we will talk a little bit about what is the difference between an AGV and an AMR, because the context has to be there. Now, the main thing about autonomous and the why I emphasize the word autonomous is that is what it is. It is an autonomous vehicle which can find its own path without the need for any external guide. Whereas in the case of AGV, you typically need a guiding system, which is either a magnetic or an optical or a beacon which guides it. Now, there are some merits of using an AMR technology. One, of course, is the AMRs can find its own way around the obstacles. So if you have a path which is a 2-meter path or a 3-meter path, and if people are walking, they're collaborative, so they can find ways around the people as it moves, which is efficient compared to an AGV, which will have to stop when there is an obstacle, and they actually move only when the obstacle moves out of its path. That is a great leap in technology, and that great leap in technology is aided by very good advancement in sensors technology like the LiDARs, 3D cameras. And those are aiding these technologies to leapfrog and be practical in manufacturing environment. So we don't need a track, or we don't need actually a dedicated path for these vehicles to transport materials anymore between point A to point B, which was a constraint in the case of the AGVs because they had to have a fixed path and it will stop during obstacles. So that's the primary variation that you see between an AMR and an AGV. What are the uses for AGVs and which industries can use it? More or less all industries which needs material to move from A point to B point. In manufacturing, there's so much of materials moving, raw materials to the lines and lines, output to the finished goods to the warehouses, in between WIP moving. So there's a whole lot of opportunity. So you can see that in automotive, electronics, food and beverages, life science, across all industries. Now, AMRs are also used quite extensively in third-party logistics. You know Amazon and Flipkart. If anybody has seen any video on YouTube on how Amazon works and how it's able to deliver so fast, it is because of the automation that goes in. So there's a lot of AMRs and a variety of AMRs that are used in the case of the third-party logistics or e-commerce world. I'm specifically talking here today manufacturing, so I want to stay focused on manufacturing. Of course, there are applications in hotels and hospitals as well. Where do you find applications for AMRs in manufacturing? Largely wherever there is material movement. So there are tow trucks. Typically, you see a towing truck pulling a couple of carts which has material in it between cells or lines within a manufacturing facility. You also have specific requirements of materials to be delivered on demand, depending on the requirement, on the shortage of the line. That also is a good application. You can also look at moving WIP from one part to another. In fact, there is one company that has been towing and has implemented this, is where they actually put the part to be assembled right on the AMR. So there's no standard moving conveyors. They actually put the whole part into the AMR, and the AMR moves from station A to station B to station C, where the assembly process happens. And if you have to just skip one station, it's just a program which does it and goes from it skips that station and goes to the next one, right? There are also other applications, like in the manufacturing itself. There's a lot of waste getting generated in the machines and other areas. So definitely those are other. And we can also look at picking and dropping of raw materials or kitted components, and those are the other areas that you can do. There are a variety of applications, but I think I'll play a video which actually explains this a little bit more clearly. So I'm just playing it, and I'll continue to talk through that. So this is an automotive plant, and an automotive plant has a variety of material movements, and this is an interesting use case. So they have these AMRs which are having a top which has got these bins in which they lock out the various tools that they need at the various stations, and these tools can be summoned on a request. So if there are common tools, so instead of a person carrying a tool or he having to walk from the real place where he is working and adding value, he probably has that vehicle going on. This is another case where you have a heavy stamped material coming out from the stamping press to a location to fold it in WIP, or it could be straight away going to an area where it is processed further. So these are heavy equipment, heavy load, transportation of equipment. When I say heavy load, it could be up to about 1,300, 1,500, even 2 tons sometimes. These are more in the electronics areas where you have shelves that carries either a PCBA, or it could carry a kitted components which is supplied to the line. And it's mostly in carts or shells, and it automatically would transfer these materials into the lines. And this is a hooking system which actually can pull any type of cart, essentially can tug any cart of any type and any size and move to the respective location. This is a conveyor on top of an AMR, which actually transports from another conveyor of an end of a line and then moves that to it. So these are just some of the ideas and use cases. And you can see in the background there just now, Kobo was putting the material to the place where it needs to be picked. So there are a variety of ideas and implementations that is possible, purely limited by the capability of our thinking on how do we build a top. Now, this is an interesting, it drops a bin and picks another bin. It can also navigate through lifts. So this is a lift on the floor, and it can move through different floors. And it's all possible to move through gates, doors, which can be opened by the control of the vehicle. So there's a variety of opportunities here. Now, it can coexist with the people who are moving material as well. So you don't really need to automate 100% of your plant to get some of these technologies in place. It can also be done partially and in a stage-wise. And this is a hospital environment. You can see that very clean, very neat, not like a manufacturing environment. So these are some of the ideas I wanted to. I think I'm my time. I had some use cases, but there's a whole lot of information that's available if you would like to look at on the YouTube, which will give you some examples. With this, I stop here because I think I'm just my time. Otherwise, I would have shown you a little bit more examples. Let's see if there is an opportunity in the panel discussion. Thank you.